Let me ask you a question. And the question is, can you say what is the weight of the earth? Answer this question in the comment below. Let's continue on the first problem. So here we have given with the weight of an object on the earth's surface, and the weight of this object is 60 Newton, right? And we have asked to find out the weight and the mass of this object which had a weight of 60 Newton on the earth's surface, and we have to find out the weight and the mass of this object on the moon. So this seems to be a critical question, but this is very easy, and let's continue. So suppose this is the object, and this has weight of 60 Newton, and we don't know the mass of this object. As we know that the mass is constant for each object, that means the mass will not change with place and time. That means the mass of this object on the earth's surface is same as the mass of this object on the moon. So if we can find out the mass of this object on the earth's surface, we can easily find out the mass of this object on the moon. So what is the mass of this object on the earth's surface? We know about the gravitational acceleration. We know that the small g, or the gravitational acceleration on earth, is 9.98 meter per second square approximately, right? And we also know that the weight, or W, is equals to m times g. Her m is the mass of the object, and the g, we know this is the gravitational acceleration. So we know the weight of this object, which is 60 Newton. So you know that we can easily find out the mass of this object, because we also know the value of this g, which is 9.98 meter per second squared. So let's reassemble this, and we find out that the mass is equals to W divided by G. And let's put the values of this, and we find out that the mass is here is 60 divided by 9.98. Let's write down this here clearly, and we find out 60 divided by 9.98, and that gives us as a value of 6.012. And yes, this is in kilogram. So this is the weight of this object on the earth, and you know that the mass don't change with place and time. So as this is the mass of this object on the earth's surface, this will also be the mass of this object on the moon. So we have find the mass of this object on the moon, and that's one of our answers. So we had two questions. Finding the number one question is finding out the weight, and the number two question is finding out the mass. So we have find out the answer of this question 2, or the mass of this object on the moon, and that is 6.012 kilogram. And let's find out the weight now. You may have noticed this text here: 1 Newton in the earth, or on the Earth's surface becomes 1 by 6 Newton in the moon or on the moon's surface. So this is a very interesting fact, and using this fact we can easily find out the weight of this object on the moon. How? Because we know that the weight of this object is 6 Newton, and we also know that on the Earth's surface, if some object's weight is 1 Newton, so in the moon or on the moon's surface that will be 1 by 6 Newton. So let's multiply this number with 1 by 6, because we know that 1 Newton becomes 1 by 6 Newton. So 6 Newton will be 60 times 1 by 6 Newton, and this will give us a value of 10 Newton. And this is the weight of this object on the moon's surface. So we have find out the solve or the answer of the first question too, and that will be 10 Newton. So when the weight of an object on the Earth's surface is 60 Newton, the weight of this object on the moon will be 10 Newton, and the mass of this object on the moon and also on the Earth will be 6.012 kilogram. So let's continue on the second problem. So where is the second problem? And let's read the question first. Suppose you have a pen which has a mass of 25 gram. Look at this, not kilogram. Here we have given with information which have the unit of gram, 25 gram, not kilogram. And what is the weight of this pen on the surface of Earth? This seems to be easier, but the main problem is here, that is here the mass is in gram, and we know that with the equation, that is weight or W is equals to mass times g or mg, where m is the mass of object and g is the gravitational acceleration and W is the weight. So here the weight has a unit of Newton, and the m has a unit of kilogram, not gram, and the g has a unit of meter per second square. That means the unit of acceleration. And from here we know that we need the unit kilogram to use this equation. So let's turn this value 25 gram to the unit of kilogram. So we know that 1 gram is 1 over 1000 kilogram. So by placing the value 25 gram here, we get that 25 gram is equals to 1 times 25 over 1000 kilogram. So by dividing these numbers, we get the answer, which gives us a value of 0.025 kilogram, right? So we can now easily use this equation, which is W is equals to mass times G, and we have asked to find the weight of this pen on the surface of Earth. So the G or the gravitational acceleration will be 9.98 meter per second squared, or this unit 9.98 meter per second squared. So of the m, which is the mass of this object, which is 0.025 kilogram, and we also know the value of g, which is gravitational acceleration, which is 9.98 meter per second squared. So we can easily find out the w here, and that will be w, or weight, is equals to 0.0025 times this number 9.98. I'm not writing the units, sir, and that will give us the answer, which is 0.025 times 9.98 meter per second square, and which is 0.2495. And what is the unit? Yes, you're right, that's the unit Newton. The weight will be 0.2495 Newton. So we have solved the problem, and we have find out the answer, the weight of this pen on the surface of earth, and the answer is 0.2495 Newton. And this is the finals. So here we come to the third problem, and here we have given with some information. So you took an object of 50 kilogram in a planet, not Earth, which have a g of 12 meter per second. Oh, that is higher than the Earth. And with how much force the planet is attracting the object. So this is not very difficult, but it has some difficulty, and this is hard to you if you don't understand the concepts clearly. So, with how much force the planet is attracting the object, which formula can be used here? If you have understood the basic concepts clearly, you know that the force the planet is attracting the object, that means with the force the planet is attracting the object, is actually the object's weight. If you have watched my previous video, you may see the link here. So if you have watched that video, you know that the weight is actually the force which is done by the planet or the earth on you. That means how with the force the planet or earth is attracting you is your weight. So this problem is actually asking the weight. That means we are asked to find out the weight. Why? Because the force the planet is attracting the object is actually the weight of the object. So we can use the formula, that's weight is mass times g, or mg. So we are given with the mass 50 kilogram, and we know the value of g, that is 9.98 meter per second squared. But this is only for Earth, and so this will not work for another planet. And for that case, we need the g of that planet, and we are given with that, which is 12 meter per second squared. I'm sorry, this will be the second squared, 12 meter per second squared. So now for that planet, which is not the Earth, use this formula, the weight we need to find. So let me put the values here, and so w weight equals to mass times g, and the mass is 50 kilogram. I'm not writing the units here. So 50 times the g gravitational acceleration, and we are given with the value of g 12 meter per second squared. So I will put only 12 here. I'm not putting the units. So by solving this equation we get the result 600 newtons. So this is the answer of this question, with how much force the plant is attracting the object, and the answer will be 60 newton. And this is the final answer of the question. So this is the fourth problem and one of my favorite problems. So here we have us that we have given these informations. Suppose you have gone underground and facing a force of 400 newtons by the earth, and you have a mass of 50 kilogram. So what is the value of G there? So from the last problem we know that the force by the earth on you is actually the weight of yourself. That means this value 400 newtons is actually your weight there underground. So we can still use the equation W is equals to mass times your mg, and we know that here the value of W is 400 newtons, and we know the m, that means the mass of yourself, which is 50 kilogram, and but we don't know the value of g, and we can, as we have these two values, we can easily find out this, and we are asked to find out the value of g there underground. So easily put this informations in the formula and we get this type of values. We will put 400 newton instead of W here. I'm not putting the unit here, and here 400 newton, or the W is equals to mass times G, and the mass is 50 kilogram. So this is 50 kilogram times G. So arranging this or assembling this equations, we get something like this. So the value of G will be 400 over 50, right? This is the value, this will be the value of G underground. So this just cancels out, and 40 over 5 is 8. So the value of G there is 8 newton. This may be something that's not easy, but as the information is given, the answer will be 8 newton. That means, I'm sorry, not 8 newton, very sorry. This is the value of G, so the unit will be meter per second squared. And this is the answer for the value of G there. So the answer of this problem will be 8 meter per second squared. And this is the final answer of this equation of the problem. So thanks for watching, and if you like this video or learned something from this video, please like, share and comment, and please don't forget to subscribe this channel You can use this automaker too. And at last, thanks for watching again.